Supercomputers have revolutionized science and industry. But in order to take advantage of the computational resources, users needed a generous amount of floor space and a substantial capital investment. The computer engineers at Sandia National Labs have taken up this challenge and developed technologies that increase computational speeds, reduce the footprint, and reduce the cost by 20%. This hardware-software solution for interconnects has been deployed in Sandia's Red Sky supercomputer with a three-dimensional Torus topology for interconnects. Interconnects are the links and switches that send information back and forth between computational elements through the computing cycle, and the way they are laid out is called a topology. Combined with Sandia's newly developed software enabling a 3D torus, this fabric allows thousands of computers to work together to efficiently communicate with each other to solve a problem. In most supercomputers, these interconnections are deployed in a fat tree topology, where switches grow exponentially to accommodate the volume of data. In this supercomputer, you see 8 racks of central switches with the requisite cables to link them, and the volume of copper cable needed is evident in this overhead view. In the Red Sky supercomputer, Sandia, together with Sun Microsystems and System Fabric Works, took up the challenge to build the first large supercomputer cluster utilizing the commodity InfiniBand interconnect technology in a 3D torus topology. With significant hardware and software development, the result has been extremely successful. There are no central switches and fewer cables, yet speed is up and costs are down. Red Sky is benefiting from this technology now with better scaling, reduced complexity, and reduced costs.
The 3D torus technology essentially creates a new mechanism for interconnecting the supercomputer components. So we move from the old style where there was a very large amount and high investment in the amount of interconnect components that you had to purchase to interconnect your supercomputing components. So with the torus, you reduce that by at least roughly 20% we've seen in the purchases that we've made. And so that allows us to put that money back into the compute infrastructure, so that 20% saved is invested back into the machine to allow for a larger machine working larger problems.
With Red Sky, a couple of things have happened. We worked with Sun Microsystems, and working with them, we integrated the InfiniBand switches into a backplane, and a lot of the cabling is actually done just with printed circuit board traces. The software was contributed to the Open Fabrics Alliance, and they have been integrating that into their OFED stack. And that's an open source software stack, and so anybody, any vendor, any other company, any other government lab can now download that and make use of that software and build supercomputers in a 3D torus topology.
Sandia's goal is to offer a hardware-software package that allows more industries and businesses worldwide access to highly reliable, affordable, large-scale supercomputing capabilities.
We've basically taken all the risk. We've done the software development. We've, matured the software, if you will, and matured the technology. And so what this will allow is other companies to be able to take advantage of that.
Our main goal out of this was not only to develop something that we needed at Sandia, but also to open up the possibilities for the rest of the industry to take advantage of our expertise and skill and collaboration with the industry to, again, take advantage of this in their particular environment so that when they see the need for computing, they can get the most bang for their buck and get their return on investment that they're looking for with computing. And that, again, will help the whole industry build up a need for supercomputing, which will make it more affordable for the national labs and other DoD groups to acquire the type of computing that we need to fulfill our jobs as well.
Whether it be in biology, pharmaceuticals, aeronautics, energy, finances, etc., with this new technology, the computer engineers at Sandia have opened the door for more affordable, reliable supercomputing systems in business, industry, and research.